you'll see this is a division problem, okay? So basically what you're doing is you're taking that bottom number and you're dividing it by each number at the top. So 9x divided by 3, of course, you can divide the 9 into 3, you're going to get 3x. And then you go the other way. You also divide the 12 by the 3. Okay, so that's plus 4. Okay, so it's just really a division problem. That's all it is. Just taking that denominator divided by each term at the top. Number 2, we're doing the exact same thing. And sometimes it might be helpful to do this. And you can separate it. Oh, sorry about that. You can actually rewrite the problem if you want, because this is really what it means. You're taking each term at the top and you're multiplying it by the term at the bottom. So when you see it this way, we know we do have our exponent rules. When we're dividing with exponents, we subtract them. So there's like an invisible 1 here at the bottom. You can leave it like it is at the top and just know that you're still subtracting your exponents. So the 5 will stay because I don't have another number to reduce that with, to divide that with. So that'll stay. And then when I subtract my y's, it'll just be y to the first. And then plus these y's on the other side will cancel out. And I'm just left with 7. Okay, because 1 minus 1 is 0. Same thing here. You're taking that denominator and you're dividing by both terms. I'm going to rewrite it. So when I divide 10 and 5, I get 2. When I subtract my exponents, I get a to the first. When I divide, 25 divided by 5 is 5, and the a's actually equal to 0. All right. Number 4. So now we have a trinomial at the top because there are 3 terms. So we're going to divide each term at the top again by 7m to the 5th. So again, I'm just going to rewrite it. You don't have to rewrite it when you're working your problems. If you want to just, leave it like it is, that's fine. Okay, to me, sometimes there is an advantage to rewriting it. So now I have 14 divided by 7 is 2. I subtract 7 and 5, I get m to the second. 21 divided by 7 is 3. When I subtract my m's, I have m to the first. 49 divided by 7 is 7, and I have m to the 0. Okay, any questions so far? Okay, now this one here, let me actually explain it first so you can see how we got that answer. So when we get to this part, it says factor. Factor means that you are looking for the greatest number that can go into both terms. So like the largest number that can go into 15 and 10 is 5. So that number then goes on the outside, and what you're doing is dividing each one of these numbers by the GCF. So this is called your GCF, your greatest common factor, that goes on the outside. It almost looks like reverse distributive property, because when I multiply it back out, it's going to take me right back to 15j minus 10. So now I'm going to divide these by 5. So 5 will go into 15, 3, leave the j. 5 will go into 10, 2 times. So if you were to check this and you multiply this, you get 15j minus 10. So you know your answer is correct. Okay, so that's how you can actually check to see if you are correct. Let's move on to number 6. Now, sometimes the numbers may not have a common factor, like 3 and 8. The only common factor is 1, because 1 can go into every number, right? So you don't use 1. However, they do have something in common for the variable, for the k's. So notice this says k to the second, and this just says k. So think about this. This is k to the second, k times k, and this is k. So when I say, okay, well, I can circle one over here and one over here, which means they only have k in common. They only have one k in common. They don't have two k's in common because I can't circle another one on this side. So your GCF for this one will be k. So when I divide these by k, that's just going to end up being 3k plus 8. And we're going to do an example in a few minutes where you have a number and a variable in common, right? So what you want to think about is when you have a variable and they both have that particular variable, but the exponents are different, always choose the smaller exponent because that is what they will actually have in common. All right, let's look at this one here. So let's look at the number first because this one has a number in common. It also has a variable in common. So what is the largest number that can go into 16 and 24? Yes.
8.
All right, 8. So that takes care of the number part. Now let's look at the variable. Which one do they have in common? Well, which one is the smaller of the two? E to the what? Second. So we're dividing by 8e to the second for both of these. So 16 divided by 8 is 2. When I subtract by exponents, it's e to the first. 8 will go into 24 3 times, and then the e squareds will be 0. Right? Okay, so let's take a look at number 8. Now, number 8 does not have a common variable because all of them do not have an r. Okay, the last one is a constant, doesn't have a variable. However, or did it have a variable? Yeah. Mine not showing? Okay, what is the variable? Mine's not showing. R to the third? Okay, thank you. All right, so mine didn't show up. All right, so they do. So that means r to the third will be for the variable. And what number can go into all of these even numbers? 2. So you're dividing by 2r to the third for each one of these. Okay, so when I divide the first term by 2r to the third, that's going to give me 5r to the second. 8 divided by 2 is 4. Subtract by exponents, I have 1 left. And then here will just be 7. Okay, so just dividing each one by 2 and then subtracting 3 from each one of the exponents. All right, so now we're going to get into what we call common binomial factor. All right, common binomial factor. We're going to actually skip to question 13. So go to question 13. We're going to come back to 9 through 12. So this is where we're going to do something a little differently here. We're going to actually, there's a method that's called factor by grouping. So underline the word grouping, because it's a different type of factoring. It's just not trying to see what all the numbers can be divided by, because in this case, there's a grouping method where you group the first two numbers and you group the last two numbers. So grouping means you're going to be using parentheses like this. So just group the first two together, group the last two together, just like that. Okay, that's why it's called grouping. Then what you're going to do is look for the greatest common factor in each group. So I'm going to look at this group first. So what's the number that can go into both of these numbers? 3. What variable do they have in common? Y squared. So I'm going to take out 3y squared, which means I am dividing both of these by 3y squared. All right, so when I divide by 3y squared, the 3's one whole, I don't need to write that. Subtract my exponent, I'm just left with y. Minus, what's 12 divided by 3 is 4, and the y's are 0. Okay? Bring down the plus sign in the middle. Now I'm going to factor the GCF out of the second set of parentheses. So what would that GCF be? 2. All right, very good. And I'm left with y minus 4. So what you notice is that these are the same. Okay, and when you factor by grouping, that is what should happen. They should always come out to be the same. They should be equal. Okay, so then what you do is you take out that common factor, which is y minus 4. Okay, put that on the outside. That will be one of your, quote, factors, because, you know, when we put them in parentheses, that means we're multiplying. Then the other set of parentheses would be your GCFs. 3y squared plus 2. So what you're doing is the ones that are the same, you're writing that here, because it's like a common one. And then the two GCFs that you took out, they go together in one set of parentheses. Okay, and I want you to see something. If I were to distribute this back out, that means multiply these two factors together. Because remember, we're talking about factors. Factors are numbers, you know, or terms that you multiply together to get a product. So technically, this is your product right here, the problem. 3y squared minus 3y cubed minus 12y squared plus 2y minus 8. If I actually multiply this back out by distributing, multiplying, distributing, and this is what I'm going to end up with. So I have just found the factors, that means what I would need to multiply together to get this answer up here. Okay, and I want you to see it. So let's actually do it. Okay, so you can see what we have actually come up with are the factors for this problem. So I'm going to erase this. And I want you to see that these are factors for this problem. That means like this is the product. So I'm going to multiply by distributing. 3y squared times y is 3y to the third. This is plus 2y. Okay, so I've distributed with the first one. Now I'm going to take the negative 4. Negative 4 times 3y squared is negative 12y squared. Negative 4 times 2, negative 8. So when you distribute the y to both and then distribute the negative 4 to both, see how we came up with the exact same answer. So these are the factors to get this polynomial. And that's really what you're coming up with. Okay. All right. So let's take a look at this one. Okay. So we're factoring by grouping. So we're going to group the first two, group the last two. So now we're going to pull the GCFs out of each set of parentheses. All right. So in the first set of parentheses, I'm going to have 5p squared. Okay, 5p squared. So when I divide by 5p squared, that's going to give me 2p minus 5. And the second set of parentheses, what is the GCF? 2. All right, and there we go again. 2p minus 5. They should always be the same. Okay. Now, it doesn't matter if you write the two GCFs together first or the common one first. It really doesn't matter. So this time I'm just going to do the outside ones first. 5p squared plus 2. And the common one is 2p minus 5. So those are the factors. That means things you multiply to get a product that will give me this polynomial. Okay, so you almost like working in reverse order. Okay. Any questions on that? Okay, here we go. We're going to factor by grouping again. So we're going to group the first two, group the last two. What do they have in common in the first set of parentheses? X squared. Very good. So when I divide the first term by x squared, I'm left with x. X squared divided by x squared is 1. Okay, a term divided by itself equals 1 whole. Okay, now I'm going to pull out a 7. Okay, so those are 7s. And again, x plus 1. Okay, so then you write your factors. I'm going to do the GCFs first. It doesn't matter. And then the x plus 1. All right, so I'm going to have you do number 16. So take a look at number 16. Okay, I'm going to group them. I want you to pull out the GCF. And actually, the second set will not even, you're going to pull out a 1. Okay, because every number has 1 in common, so we got to have a number there. So the only thing you can take out in that second set, so it's not going to change the second set if you divide by 1. So go ahead and see what you get. Okay. All right, so what you should have done was taken out a 5r squared for the GCF. And then here, the only thing they have in common is 1, so it's not going to change that. You put your outside GCFs in one set of parentheses. That's 5r squared plus 1. And then the common one is 3r plus 8. Okay. So now what I want you to do is go back to number 9 through 13 because they've already done the grouping for you. So that's why I kind of did it in reverse order. Okay. Go back to question number 9, and I want you now to go ahead and just put what the factors are as the end. And okay, so for number 9, like I said, it's already have been factored by grouping. So you just say x plus 9. It doesn't matter again which one you write first, and 6x minus 4. Okay, you take your 2 outside GCFs. For number 10, same thing. Okay, let me not move that. Take your common one times your GCFs. Okay, so they were actually already set up for you. 11, same thing, common one, and the GCFs on the outside. And the last one, same thing, your common one. And remember, there's a 1 here. Okay, so the last one would be 9z minus 1. Okay. All right. So that's the lesson on that section. We're going to move on to doing some problems together in your packets. Okay. Okay, guys, so on page 1, and I'm not going to be pulling it up, I'll just be writing the problems down. So on page 1 in your packets, you're just dividing that denominator by what's at the top. So I'm just going to do a couple of these with you. So look at question number 11 on page 1, where you have 8a to the third plus 4a to the second minus 24a, all divided by 4a. Okay. So if you feel like there's enough space here, you can definitely just do it here. If you feel like you want more space, you can definitely use your spirals. Okay. So what I'm going to do, because I'd like to have the number under each one, this is what I'm going to do. I'm just going to put the 4a under here as well as the 4a over there. Okay. Because I know I'm dividing each term by 4a. So when I do that, 8 divided by 4 is 2. I subtract my exponents. That'll be a to the second. Okay, that equals to 1 whole. When I subtract the exponents, that'll just be a to the first. And then at the end, the a's cancel, and 24 divided by 4 is 6. So you can just simply take what's in the middle and put it on both ends, and it helps you from having to rewrite the entire problem. Okay, so then you should be able to find your answer off to the side. Okay, all right, go to page 2. So this is the factor by grouping that we just did. So if you want to put at the top factor by grouping, that's up to you. Okay, so this is for page 2. So for page 2, let's do number 1. So number 1 says x squared plus 3x plus xk plus 3k. So we're going to group the first 2, group the last 2. And what can I take out of that first set of parentheses? X. Very good. So when I divide these by x, that's just going to leave me with x plus 3. Second set of parentheses, I can only take out a what? A k. So when I divide by k, I'm going to be left with x plus 3. So then my final answer, x plus k times the x plus 3. Okay, so that's exactly what we just finished doing a few minutes ago. All right. Now, I do want to do one that has a minus sign in it, because we like a minus in the second set of parentheses, because that does change the sign. Okay, so let's look at question number 11. We're on page 2 still. Okay, so in question number 11, we have m squared plus mn minus 3m minus 3n. So when I group these, I'm going to take out an m, and then over here, I'm going to take out a 3. Now, see how this is a plus here? This actually changes to a plus as well. Now, why? Why do you think this changes to a plus? Right, because you're doing the opposite because of the subtraction sign. So we've done a lot of examples with plus signs in the middle. Be very careful when there's a minus, okay? Because the minus then changes the sign inside, all right? So just be very careful, all right? So let me finish. So then I'll just have m minus 3 times the m plus n. So I just want to point that out. The minus will change, that sign that's inside of the parenthesis, okay? All right, great.